Hey, Algebra 1, here's page 3 of our Interim 3 test review. Whenever we see these vocabulary words like roots or solution set, solutions, and so on, they all mean the same thing. So roots are the same as solutions, are the same as your zeros that we talked about for the last test, and they are all the x-intercepts. So we are going to graph every single one of these on Desmos. The first thing you look for, does it already equal 0? Yes, it does. Number 7, does it already equal 0? No, it does not. So I need to do the opposite over here, and then I'll have 2x squared minus 7x plus 3 equals 0. That'll be ready for graphing. Looking at number 8, this one is already equal to 0, so that's great. Part B is not, so again, because this is a minus 9, we need to add 9. And then I have x squared minus 6x plus 9. Now it equals 0 because negative 9 plus 9 is 0. So that's the first thing to look for when you are doing this type of, answering this type of question. So next, you go to Desmos and you graph it. And when we look at this graph, remember that you are looking at quadratics, U-shapes for all of these. We're looking for where does it cross. And right here and here are the solutions or the roots. And I can put it in our fancy braces, -7, -2. Matches exactly where it's crossing on the x-axis. That's your x and that's your y. Same thing for number 7. I put in everything up until the equal sign. And this time, my graph actually is more on the positive side because I end up with a parabola, something like that. Once again, I'm looking for exactly where does it cross, and it crosses at 1/2 and at 3. Now, this was not the only way. We also could have factored. So if we go back to number 6, we could have factored this into x plus 7, x minus 2 to get that, or x plus 2, excuse me, and then each one of these, when I set them equal to 0, gives me these results. Same with number 7. If you had factored it, you would have ended up with x plus 3, which would have given you, or excuse me, x minus 3, which would have given you the positive 3 as a solution when you set it equal to 0. And then you would also have your 2x minus 1. And when you set that equal to 0, that would give you the positive 1/2. Okay, but the quick way really is to make sure it equals 0 and then graph it. Number 8, when you graph it, it will look something like this. Here's your x, and your graph is crossing over here at -6 and -1. With this one, when we graph it, this one is kind of a special situation. It actually only has one answer because it is coming down, touching, and then going back. So it only touches in one place, which is positive 3. It's called a double solution or a double root when it just touches one time. Now, moving on to number 9, now we're getting into our radicals. So it is basically asking us to simplify all of these. Okay, we want to have the simplest radical form. And then we'll pick out the ones that are simplified and which ones are already simplified or ones that are not, and then we'll take care of those. So if I look at 126, I'm going to divide it by 2 because it's not a perfect square, and I get 64, which is a perfect square. So I stop and I write down my 64 and my 2. Remember, I can separate those, and then the square root of 64 gives me 8. The square root of 2 stays. To check in Desmos, you could put this in line 1, put this in line 2, make sure they match. Okay, look for a match with their decimal values. When I look at B, the 6, I can only break down into like 2 times 3, 1 times 6. Those are not perfect squares. So it is already simplified. Okay, it's already simplified. So we would add that to up here. We would say B is already simplified, and A is one that we had to simplify ourselves. Looking at C, inside we have a 5 and a Y. We can't do anything with that. So again, this one is already simplified, and we'll add that to our list up here that they're already in simplest radical. In D, first of all, I have a 20. Okay, so right now I know I can break that down. If I divide it by 2, I get 10. That's not going to work. If I divide it by 3, nope. If I divide it by 4, well, 4 is a perfect square, and I get 5. So this one, I am going to break the 20 into a 4 and a 5. Now, my x to the 4th, that's already divisible by 2, so let's leave that alone. The y to the 5th, we drop it down 1 to 4, because that will make divisible by 2, and then we leave the other one here. So now let's separate them. Square root of 4, square root of 5, square root of x to the 4th, square root of y to the 4th, and then the square root of y, or y to the 1st. Now the ones that can move out are the square root of 4, which is 2, the square root of x to the 4th, which is x squared, the square root of y to the 4th, which is y squared. The ones that have to stay are the 5 and the y. So this one gets added up here as one that we can simplify further. E, 72. When I divide it by 2, I actually get 36. So there you go. I can break this down into 36 and 2. The x I can't do anything with. The y cubed would be y squared and a y. That's a 2 up there, and y to the 1st. So this would be 36 and 2, and the square root of x, the square root of y squared, the square root of y. Which ones come out? The square root of 36 does, and the square root of y squared. But these all have to stay. The 2 and the x and the other y will stay. And we'll once again add this to our list of ones that we can simplify. Then F, 113. Test it out. Can I divide it by 2? No. Can I divide it by 3? No, that's not going to work either. 4, no. 5, no. 6, 7. This might even just be a prime number, and I can't divide it by anything. Okay, so that one is already in its simplest form. I can't break it down, so I will add that up here as F. And then we have 2 more. Well, goodness, this is definitely going to be simplified, right? So let's work with the 125 first. Divide it by 2, nope. 3, no. 4, no. 5, yes. If I divide it by 5, I get 25. So we'll do 25 times 5. And then 9 needs to be dropped down to 8 and 1 more. Oops, that's an x. The 2 stays as it is, y squared. And the 6 stays as it is because, again, those numbers are divisible by 2. So let's separate them out. I have a 25 and a 5. I have an x to the 8th and an x. And an x. I keep doing that. I have a y squared and I have a z to the 6th. So the ones that move out are square root of 25 is 5. 8 divided by 2 is x to the 4th. Y divided by 2 is y to the 1st. And 6 divided by 2 makes z cubed. Now the ones we didn't use, maybe we should just cross those out as we use them. The ones we didn't use are 5 and this x. So that is our result. And we'll add g to the ones that we needed to simplify. All right, let's move this back. And we have one more to do here. We have 27. Can we break that down? Let's see, 27, yes. We can break it into 9 and 3. 8 is already divisible by 2, so let's leave that. Y fourth, that's good to go. 5, we have to break down to 4 and one more. Square root of 9, square root of 3, square root of x to the 8th, square root of y to the 4th, square root of z to the 4th, and the square root of z. What can move out? The square root of 9 is 3, okay? 8 divided by 2 is x to the 4th. 4 divided by 2 is y squared. 4 divided by 2 again gives me z squared. And then what stays is the 3 and z to the 1st. So remember that underneath your radical, whatever is left here with the variables should not have anything more than a 1. Okay, see how there's not a 2 or a 3 or anything there? It should just only be a 1. Well, that ends our third page of our review. I'm going to stop the video here and start a new one for page 4.